Welcome to this Gestalt IT Tech Talks Roundtable discussion brought to you by Solidigm with their guest Supermicro. In this Tech Talk, we're going to be meeting with a group of IT luminaries to discuss the topic of bringing next-generation SSD to enterprise and the cloud. Before we begin, let's quickly meet who's on the panel today.
Hey, my name is Tahmid, and I'm the Director of Product Marketing from Solidigm.
Hello, everyone. My name is Patrick. I'm the Supermicro's Flash Storage Director. Nice to meet you guys.
Hello, everyone. I'm Max Mortillaro. I'm a storage analyst at GigaOM and co-owner at Tech Unplugged.
Hi, my name's Andy Banta, just general storage person. You can find me at Andy Banta on Twitter.
And I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT, and you can find me at sfoskett on most social media networks. So now that we've met who's on our panel today, let's get into it. As I mentioned at the top, we're discussing next generation SSD and the impact that it's going to have on enterprise and cloud servers. That's why it's exciting to have Supermicro joining us as well as Solidigm, because these are two companies that are absolutely developing at the forefront of developing advanced storage and server technology. First off, though, let's kick things off with discussing the challenges that today's business face. Why would a company be concerned about storage, and how would they pick the right type of storage for their workload or other business requirements? Let's start with Tahmid.
Hey, thank you, Stephen. I think the challenges are, threefold from where we are seeing things. Number one is, the data growth has been phenomenal, right, over the last few years. Think about this year alone, we will be growing 3x the data that we used to have in 2019. And by the year 2025, the data growth will be up to like 181 zettabytes. That's like 18 zeros after 181. So where is this coming from? This is coming from, user trends, more AI and ML specific workload that's hitting us. And then this data growth is also that problem of the data growth is also compounded by the fact that a lot of hardware needs to be refreshed. If you think about storage, some study shows that 85% of storage is still running on hard disk drives, so that needs to be modernized. The other challenge is, as the SSD technology kind of develops, there is more and more investment on the SSD technology in terms of the growth rate, almost 4.5x. compared to compute expense. So coming from those challenge areas, we see that there's a tremendous opportunity to kind of optimize storage, give the right size of the storage to the end user, and keep up with the data growth rate. I think those are some of the challenges, but I would say there are also opportunities for us.
Yeah, definitely. As a Supermicros, and we are working very closely with our customer. And we know the IT industry are facing many new challenges that are not existing before. As Tahmid mentioned, the data growing, the challenging of the capacity, it requires a new storage technique to handle the exabyte data more efficiently. The second challenging we talk to the customer and found out is the scalability and the performance. The next wave of the modern applications call for the performance and the scalabilities, but it won't compromise within the quality of service or service license agreement, right? The third one is the operation efficiency. To support this disruptive growth of the workloads, you can easily to add more servers, more the SSD, more the hard drive to achieve that, but they will definitely increase your total cost of ownership. How could you solve the capacity challenging, scalability, and the performance requirement, but still keep your TCO in check? Optimize and the utilization is the key for the modern IT industry. So that's why we are working closely and innovate a new storage platform, and also work closely with our partner like Solidigm to invent this new petascale storage product line.
Can you explain a little bit about what your solution is to actually solve these? You've covered the problem statements, and how about if you tell us how you're actually solving these problems?
Yes, thank you, Andy. Yes, Supermicro, we are the pioneer to working on this new next generation EDSFF or flash system. And as you guys may know, we are the pioneer to working on the Intel Ruler SSD or the E1 SSD in the past couple years. And we understand customers always looking for a better storage platform and for the new data-centric workload to resolve all the issues and the concern we just mentioned. Now we are working with the next generation PCIe Gen 5 petascale storage, which can hold in one use form factor, we can hold a 16 E3 SSD. In the 2U system, we can hold up to 32 E3 SSD. And this new platform can support a single socket AMD Genoa, or we also have the platform to support the dual socket Intel Sapphire Rapid. This is a purpose-built all-flash storage designed for the all-flash system. And also we are partnered with the Solidigm incorporate their latest storage media to serve the next generation's data center workload.
Yeah, I think what Patrick was saying is right on the target, right? So from Solidigm point of view and from the storage point of view, we see that, yeah, data growth is there. Patrick talked about the 32 terabyte that Supermicro is offering. But what is that, data pattern or the workload pattern that we are seeing? It's varied, right? You think about like your thumbnail images like 64K. If you go to 1 megabyte size, which is your large data structure, even like more than 1 megabyte, 64 megabyte is around your big data analytic data sizes. So not only the data sizes are different, the access pattern is also different. In a large study done by University of Toronto, they have been showing that out of 2 million SSD analysis, most of the workload that an top enterprise customer is seeing is mostly read intensive. Around 94% of the workload is read intensive, like 80-20 read write mix. So what does it mean to a storage vendor like Solidigm is we have to create the right SSD to meet that data growth and the performance for the right workload. And that's what we have been bringing in to the market. We're going to talk about D5P 5430 in this event. This is the drive that is right now available from us, and that's what Patrick is also helping us to design in. So where these drives come into picture is that unique swim lane to address that read intensive workload, not only having the right performance, but giving the right capacity growth and meeting the right capacity growth for that segment. I think we're marrying the performance and the density together to bring the right SSD to the market.
Yeah, that sounds reasonable. You started to touch on this, but can you explain a little bit how you expect storage density to keep pace with increases in CPU efficiency, memory density that you find with CXL type systems, that type of thing? Can you tell us how the newer generation of PCIe buses and processor architectures are working with what you're attempting to do?
So absolutely, I think we have made the transition to PCIe Gen 4 as a widely available interface. So most of our products are being designed on PCIe Gen 4 and been shipped on PCIe Gen 4. In future, we'll be bringing in PCIe Gen 5 also. The main market is still at that interface level. So you'll see that as we go from one generation to another on the QLC based SSD, our bit density growth is 50% or above, and trying to keep up with the core count and the memory lanes and the PCIe bus lanes. We're also keeping up with the density points, right? So today we have launched the 32 terabyte. Second half of the year, we'll be bringing in the 60 terabyte. The customers, as I mentioned prior, the sweet spot of density and performance combination, right? That's what we're trying to hit. I mean, basically maximizing the PCIe Gen 4 bandwidth on these devices on workload that matters, and at the same time, basically meeting that insatiable need of density that we are hearing from most of our tier 1 customers.
So can you elaborate a bit more on the form factor that you're using? I think it's the E.3 EDSFF on this chassis?
Yes. So D5P5430 is launching the first E3.S from Solidigm. This is a very unique form factor with a lot of innovation around it. Andy brought up the discussion about going from PCIe Gen 4 to Gen 5 and beyond Gen 6 timeframe, right? So if you fast forward ourselves to Gen 6, we think that this form factor is ready now, and it will be much more suitable for really high frequency interfaces because of its really robust signal integrity and less loss, insertion loss, up to -2 dB insertion loss improvement over the existing U.2, U.3 in Gen 6 timeframe. So basically what we are doing is we're trying to pave the way with the new form factor E3.S now, so that, customers like Supermicro, who are really trailblazing with us on this journey, get this enabled now on Gen 4, Gen 5, and then when Gen 5 comes, it becomes a really more widely adopted form factor. And not only that, it actually gives you a better thermal efficiency on an ISO density and ISO Z height level. It provides you better efficiency in scale because you can actually jam a lot of these E3.S on a 2U form factor up to 48. In this case, Supermicro has 32 of them. Gives you really dense, storage footprint. And what it does is basically it helps us on the sustainability. It's a great green TCO story because it is reducing the footprint of the server by 5x. It is reducing the power consumption by 1.9x, and it is actually increasing, your benefit and reducing your TCO for your environment.
So I wanted to circle back on the topic of density that you were pointing out. So I think you kind of partially answered my question in terms of the benefits. First of all, in the scalability at the chassis level, the density that you achieve there, and also the scalability. So that brings me the question to, or rather who are you, what kind of use cases or markets are you primarily targeting with that? Because those systems are very, very dense, much more dense than regular, servers, for storage. Is there anything particular there that you're aiming for?
Absolutely. I think there's some really good use cases that this class of drives, along with the Supermicro systems, will be deployed. And think about really dense object storage. You think about content delivery networks, streaming media. Just to give you an example, D5P5430, it can write all the way up to 105 petabytes in its lifetime. Think about that for a moment. You have half a terabyte of write capacity per hour. What does it translate? And that half a terabyte is a completely random workload pattern. If you're doing a CDN type of network, you're probably writing sequentially, right? And in that case, it's probably 2.4 terabyte per hour of media or whatever you want to put in the media in the SSD. And that translates into 600 high definition movie in every hour. And you can do it 24/7, 365 days a year for 5 years without wearing out this particular drive. So that's the kind of endurance we're talking about with this new 4th generation QLC based SSD. Enables CDN, enables object storage. It enables online application processing. I talked about the workload pattern. These workloads are more read heavy. They're more on the high transfer sizes. They're more sometimes random, sometimes mixed. But overall, the endurance level of these drives is absolutely, not going to be an issue, which is basically the reason I'm talking about is sometimes there's a myth that QLC wears out faster, and whether the QLC is the right drives for this or not. But across these different workloads that I talked about and many more, general purpose server, think about AI, think about ADAS. These are the type of workload that will actually benefit from the right size of SSD, because the industry has, evolved into kind of got comfortable with a one drive writes per day paradigm where one drive fits all applications. We don't see it that way. And that's where these drive and this class of systems will come into, picture, where it actually disrupts that swim lane and creates a unique swim lane for a whole bunch of workload where you can actually reduce your TCO, reduce your footprint with much denser storage with the right performance that matters for the right workload.
I wanted to come back and complete the question that I asked previously. You covered some of the information about PCIe Gen 5 and Gen 6. Maybe Patrick can address some of the ways that Supermicro is going to be using new processors to take advantage of these or to make use of these protocols.
Yes, definitely. Right now, the CPU and those components evolving very quickly. And right now, we are talking about this next generation petascale. We are leveraging the PCIe Gen 5 architectures. This is a brand new design, and both from Intel's Sapphire Rapids and the AMD Genoa, they have the new architectures, more PCIe LAN, better performance, and much powerful CPU compared with the previous generation. With these new CPU architectures, for example, in our design with a single Genoa, we will have a 128 PCIe LAN, which is a PCIe Gen 5. So we can easily to support a 32 by 2 SSD, and you still have the 64 PCIe LAN, which can support a 4 networking card in the real side. This is the well-balanced design system from SSD to the real networking. In the AMD design architecture, each Sapphire Rapids CPU is 80 PCIe LAN. We have a dual socket. You will have the 160 PCIe LAN inside the one box. So you can serve the 24 by 4 SSD, and you also have the 4 PCIe networking OCP NIC in the real side. By this new technology, it helps us to reduce the PCIe switch requirement. If you guys remember the Gen 3 systems and due to the PCIe limitations, when we do the all-flash array, we need to put a kind of the PLX, the PCIe switch to fend out this PCIe LAN. The one is increasing the cost. The PCIe switch is increase the cost. Second, you induce the latency and the system complexity. With these current new technologies on the CPU architectures, they will make the system very straightforward, simple. CPU PCIe LAN to the SSD, CPU PCIe LAN to the real networking side. So it helps us, the platform manufacturing company like us, to simplify our design, lower the BOM cost. And of course, coming with the PCIe Gen 6, it will be more performance and easier help us to consolidate the performance requirement or the density or capacity requirement. Yes.
Yeah, it really seems like the improvements brought by these next generation server platforms really work nicely, dovetail nicely with the improvements that are coming with these next generation SSDs and next generation servers. All of them have a lot more bandwidth, as you mentioned, a lot more PCIe lanes, a lot more CPU power. And of course, that demands a lot more storage capacity and performance. And yet here we have a product that brings that to the table as well. So all of these things mix so nicely together. It seems, though, that all of these products are increasing. Well, I think maybe people would jump to the conclusion that all of these things are just going to increase performance, but it might also be about other aspects too, including density, power drain, and power demands and scalability, right?
Yes. When we design the system, it's not just for the performance or only, right? And we know the IT industry is more focused on the efficiency and the green IT, right? The reason we design this high density and high performance system also collaborate with Solidigm's new generations, QLC SSD. We try to help the IT industry to consolidate the workload, right? And the consolidated workload, if a customer requests more performance, they can upgrade from the spindle hard drive to the SSD. Then you still with the limit 1 or 2U form factor, you can achieve that performance goal. On the other hand, it's the density. With our 1U system, 16 times 32 Solidigm SSD, you can have a half petabyte. And in the later this year, they will have the even higher density. We can reach the 1 petabyte in 2U form factors. You can see this is increase the density and reduce the power. And this is the key goal. We want to help our partners, our customers, the new IT infrastructures to reduce the operation costs, reduce the footprint, reduce the cooling requirements.
I completely agree with that. I mean, this is an excellent, combination of high density storage with high performance server, as you mentioned, Stephen, high performance CPU and memory bandwidth. I just wanted to quote one thing. Like basically, we were looking into a 7 petabyte object store design, which is going from a overall all HDD to the new generation D5 P5430 30 terabyte, the one that Patrick actually talked about. And from a power, you brought up power. That's what I'm talking about. It. So power, I mean, basically 1.9x higher power density if you move to these class of SSDs. And then with that, along with that comes 4x lower energy costs. So as the data centers of now and future talking about sustainability, green data center, and reducing the cost, right? These are really critical and vital for the data center ecosystem to have the right density and the right performance, because we don't want to oversubscribe, over provision these drives, which we have been doing. So that's why we introduced this new swim lane called Essential Endurance, which actually helps you to optimize your data center footprint with the right type of storage in it.
Yeah, and I had a question related to that. And again, you're really good, Tahmid, because you're really answering well and ahead of what I want to ask somehow. But obviously, we can see straight away the straight out the benefits that we're getting here in terms of storage density and what it brings to sustainability. One of the usual concern is in terms of power efficiency. If you look at it at the petabyte level, for example, you can have a solution which is much more energy efficient, while another will not be such as efficient, as that. But do you and that my question is more a more global consideration. Are we going to see in the future those benefits in all of these new systems which are going to be released using the new EDSFF form factor? Right now we're using you're talking about the E.3 on your SSD drive. But is that something that we can expect going forward from all of these new architectures?
Yes. So I want to answer it in two ways. One is it's not only about E3.S form factor. We're enabling other form factors too. And Max, you're right. Again, we don't believe in one size fits all, right? It's not U.2 in some cases still works fine, right? There is innovative solutions on high dense storage, which is really density optimized, which will basically take advantage of the E1.L form factor, which we are shipping right now. And then on the compute side, you're talking about E1.S, right? Slightly lower density, maybe based on TLC SSD, which also we offer in our portfolio. So basically, the efficiency of EDSFF is across the board. It's at the compute, it's at the 2U server where you want to do optimize for density with E1.Ls, which also have thermal efficiency. And then on top of it, with the existing U.2 replacement story with E3.S, both in 1U and 2U form factor, where performance and density both plays well. So yeah, it's going to be end-to-end revolutionization of data center with the right form factor, and that's how we view it. And I think EDSFF will be at the core of those innovations and those optimizations for the data center of the future. Because right now we are basically we were within the straitjacket of a U.2 form factor, inherited from the HDD time, right? So EDSFF is truly a grounds up design that liberates us from that straitjacket of within an HDD form factor for over a decade or so. So I think it's the time to embrace the new form factor with the right density and with the right performance profile of these SSDs.
Well, I wanted to ask a question about how you see the market adopting these, and who might actually be using these. With the hot pluggability of these pieces, it seems to me that you're almost building a composable infrastructure platform. That with the PCI switching that Patrick was talking about. Can you tell us where you actually, who you might think would be using these and how it might be used?
Sure, I can take it first, and then I'll let Patrick to comment on it. So, what I said prior, right? Storage optimized dense server. So those are the areas that E1.L is aligned to, and we're enabling hyperscalers, tier one hyperscalers, and storage innovators in that area. E3.S will probably be adopted first by the tier one OEMs to get to Gen 5 and beyond that. There will be a lot of Gen 4 designs on E3.S as well. And it'll be for, again, storage innovators, tier one OEMs who would like to get more denser design. Example, Supermicro over here, already enabling E3.S in their system. And again, a wide range of applications ranging between CDN, object storage, ADAS, AI, ML, data analytics, right? General purpose server. It's a wide adoption, but it's gonna be taking some time, Andy. If you look into some of the industry analysts, they're predicting that by 2026, 50% of the market, or even more than 50% of the market, will be adopting some form of EDSFF form factor. M.2 is definitely going away because you mentioned hot pluggability issues. EDSFF form factors do not have that limitation because they share the same connector, same architecture. So basically, it'll be E1.S, E3.S, and E1.L combined will taking over the market more than 50% by 2026. And we see the transition right now. Again, going back to the University of Toronto study where they actually looked into almost 2 million SSDs across different interfaces, SAS, NVMe, MLC, TLC. And then they actually asked the question, how many of these SSDs we can convert to QLC without impacting performance and density? And then the answer was an astounding 95%. And they were assuming about, I think, 3K P cycle, which we are already on Solidigm SSDs. So think about it. Like if you want to really use that sustainability message and drive more innovation in your data center, QLC data center SSD is the right one to go with because that's the right size. You don't want to pay the unlimited mileage if you're just driving to the nearest, airport, right, for your rental car. So we are right-sizing everything. Why not right-size our storage and data center?
Yeah, I totally agree with Tahmid. As I mentioned earlier, Supermicro has been support Intel Ruler over the earlier E1.Long a couple years ago. At that moment, this is kind of innovations, and lots of customers is watching and try to understand the benefit. But you can see in this past year and this year, all the SSD major vendors start to support the EDSFF form factors, no matter from E1.S or E1.Long or E3, right? So you can see, especially as Tahmid mentioned, the EDSFF provide a much better signal integrity. For right now, the PCIe Gen 5 in the couple years will be Gen 6, and this will be critical. We can support the newer generation high frequency storage. We engage many customers. Customers start to kind of looking at this platform, and they understand the benefit from the EDSFF and also the require higher density. As 1U, right now we can do the 16 drive compared with the traditional legacy U.2. You can only put a 10 drive. Consider this is a 60% increase the density in the 1U space, and the 2U 32 compared with the traditional 24, right? That is a 30% increase the density. And you increase the density, better performance, and you have a better signal integrity. And plus, with the same family, you can support E1.S for replace the U.2, M.2, and for the small form factors. And over the E3, replace the U.2. The E1.Long is focused on the hyperscaler. So you can see one family, you can support a different application, different vertical. And not like a traditional U.2 has been designed for the SAS SATA SSD. I think it's more than 20 years, right? And this is new form factors. And we are excited to work with a partner like Solidigm to continue this journey and promote this new form factor and the new next generation petascale storage.
Yeah, thank you for that, Patrick. And Tahmid, ultimately, I think that that's really what's going to cause the customer adoption is the compelling nature of the complete systems delivered by companies like Supermicro, as well as, of course, the major OEMs and ODMs, and of course, cloud users as well. They're going to see the benefits of these new form factors. They're going to see the performance, the density, the power efficiency, the new high performance IO interfaces, and they're going to adopt these because they provide compelling benefits to users of the systems, all the way from performance and scale to sustainability. So thank you so much for this wonderful discussion. I really appreciated having Andy and Max bring your questions to the table, and I really appreciated having Tahmid and Patrick here to answer these questions in this special Gestalt IT Tech Talks roundtable discussion. Before we go, though, let me just quickly go around again and ask you, where can we follow you, where can we find you, and where can we continue the discussion on next generation SSD and next generation system architecture?
Yes, Stephen, yeah, it was a pleasure to be with you guys. Excellent discussion and questions. If you have more questions around Solidigm SSDs and products, visit us at solidigm.com. And also, I mean, reach out to me through LinkedIn. I'm there. So use my LinkedIn account and reach out to me with any sort of question.
Yeah, same here. I appreciate this opportunity, Stephen and the team, and also Tahmid, glad to work with you on this next generation storage. And for the more detail about the petascale all flash, you can reach out to the www.supermicro.com and for the detailed spec. And of course, you guys can reach me through the linking. And if any questions, and please follow us. We will continue to release the more next generation all flash storage there. Thank you.
And you can find me on Mastodon. It's at Max Mortillaro at eigenmagic.net. You will find the link probably in the description. And you can find me also on LinkedIn or on my blog at techunplug.io/blog.
And you can find me at Andy Banta on Twitter. I'm on LinkedIn as well. I have a freshly kicked off blog, andybanta.substack.com. And if you're interested in talking to me more about storage and memory, I'll be presenting at the SNIA Compete Storage and Memory Summit. Thank you very much.
And as for me, you can find me here at Gestalt IT, as well as our podcasts and videos on YouTube and at gestaltit.com. Thank you so much for joining us for today's Gestalt IT Tech Talks roundtable discussion. If you enjoyed this discussion, please do subscribe to the Gestalt IT newsletter at gestaltit.com and look for additional videos and articles. You can find those on YouTube at youtube.com/GestaltIT-video. This roundtable discussion was brought to you by Solidigm with special guest Supermicro, as well as gestaltit.com, your home for IT coverage from across the enterprise.